Today we are going to understand one of the important microservices design pattern, which is transactional outbox pattern. First of all, let us understand what is this pattern, and then we will go into the pros and cons. So here we have the application. Application stores data in some business table, and we also want the data to be sent to various other services. It could be like some email notification to the payment service. I mean, this is the order service, right? So order has been created. So this order service needs to inform payment service. There should be some email gone to the customer, or the order is created to the inventory service and to the analytics as well. Now, how do we do that? Suppose if we don't have this outbox pattern, say there is directly a message broker here. I insert this data into business table and I also put it in the message broker. Say I do a commit, or basically I finish the transaction once it is committed in the database, and then I call the message broker. Basically, I put it into the message broker. But say while I'm putting into the message broker, it fails. There is a failure. It can happen, right? Instance can restart or anything can happen. So the data was committed, order was created, but there is a break in the flow. Your queue didn't get the information that order was created, and these consumers didn't know that the order was created. So this is one problem that we face. So this can be resolved with this pattern. So we first put it into the database. At the same time, we put it in the outbox table. This is the table which will be used to publish data to the message broker or to the queue. So once we commit data in these two tables, only then my transaction is complete. So this is my functional commit which happens here. And in case either of them fails, we roll back. The order is not created. Now what happens once this is successful? There would be a polar process which will be reading from this outbox table, and for reading it, it will put it into some queue. It could be Kafka, RabbitMQ, etc. And then these consumers would be polling the basically the Kafka queues or so these. This is the way we can make sure there is no break in the flow. Once order is created, all the consumers will be surely updated that the order was created and they can go ahead with their next process. So just to recap, the first client sends a request to the application. Application performs a local DB transaction, which is basically your functional data is inserted. There is order table, and then you put it into the outbox table. Here your transaction is completed, order transaction. And then there is outbox relay or publisher. It will pull this data table, sorry, and then put it into the broker, message broker. And the consumers can actually consume the data. So what are we achieving here? No two-phase commit. If there was two-phase commit, because this is a distributed architecture, so you would have to wait actually for all the players to actually tell you that okay, they have completed the transaction from their side. It assures atomicity, that is basically your database changes as well as your message publication. So even if there is a failure after this database transaction is completed, this polar process will, based on the status, will read from it and then put it. If the status is pending, that means that is yet to be put into message broker. So in this way we handle the atomicity. Messages are lost. Scalable as well. You can have multiple instances of outbox if you want, if the number of orders are increasing. and complete asynchronous process. So this is the transactional outbox pattern. And what are the key components? Obviously, you have the business table, you have the outbox table here, you have the outbox relay process basically, and then there is a broker and consumers. So thank you so much. This was all about transactional outbox pattern.